Welcome to ThoughtWorks. This is our community space. We're the most social office that ThoughtWorks has. The New York office does so many things in the community, social good projects. We host user groups and meetups constantly because we believe sharing knowledge is really the key to making better products. Also, having diverse teams. So in that, we're always looking for new people with interesting backgrounds, with different or very niche skill sets. So if you are interested in some of the work that we do, how many people know of ThoughtWorks? Does anybody know of the work that we do? Okay, 1, 2, 3, 5, 9, Uri, Diego. Oh, and Dan. You guys are here too. They work for ThoughtWorks. They are part of one of our blood client teams right now. One of the clients that we have that brings in a ton of money. So we don't really talk about that kind of stuff. We like to talk about what that money pays for. We're a 3-pillar company, and does everybody know about the 3-pillar company system? The business model. It's kind of like Ben and Jerry's. Actually, I think we stole this business model from Ben and Jerry's. Ben Cohen was in our Chicago office once talking about ice cream and his business model. The first pillar is to be sustainable, so to run a business and actually pay your employees and have a living wage and blah, blah, blah. The second pillar is to have the best product. So, of course, Ben & Jerry's has the best ice cream. ThoughtWorks has the best software. And the third pillar is our social justice component. It's where we do good work in the world. And because Dan and Diego are on this team that just rakes it in, you know, they're making bank, we get to take that excess revenue and put it into our third pillar, our social justice pillar, where we do all of this amazing work all around the world for clients that we can talk about, like Democracy Now!, Homer Learning, Amplify for Education, Sankofa, which is Harry Belafonte's foundation. We now have 29 offices that do socially good work, and like large clients like the world's leading search engines and airlines that fund these projects that we have, these social good projects. So that's really what ThoughtWorks does. And if you want to learn more about that, talk to these two gurus, these dev gurus here, or myself, or just take a walk around the office. I mean, our office is open for the walk-in. And did I get a snap for that one too? I mean, thanks. and just go talk to people. We've got, I think, 2 or 3 other groups using our space tonight. Hardware Hack Lab, which is a bunch of hardware enthusiasts hacking away at Oculus Rifts and iBeacons. Dan, you're an expert with iBeacons, right? Maybe you're going to head over to Hardware Hack Lab afterward. We've got a video meeting and I think a black media meeting as well. So, I mean, ThoughtWorks is, of course, involved in all these different areas. So if you have any questions, come talk to us. If you feel like tweeting or sharing what you're learning tonight, tweet at ThoughtWorks or Elasticsearch or MySports195 or ubonus, right? Hashtag ThoughtWorksNYC. And if there's enough activity, I'll get a text from our lonely social media manager, Wesley, in Austin, Texas. She's just sitting all by herself down there. But she'll text me if there's an outrageous amount of tweets happening, and we'll give away some prizes, like movie tickets or maybe a Martin Fowler book. So feel free to share on social media. If anyone has not yet logged onto the wireless, it's TWGuest and disruptive in quasi-geek speak. It's all lowercase. The I's are replaced with the number 1. And the restrooms are past the beer, through the kitchen, immediately to the left. But if you just wander around, you'll find them. Cool? Good questions? We do use Elasticsearch. That's exactly why these two are here. How big is your team, actually? 12 people? Are there other teams that use Elasticsearch? I know that we have on past projects, but current projects? Okay. If the camera couldn't hear Diego, there are 3 teams in Brazil using Elasticsearch. But Diego's Brazilian, So I guess, yeah, case, yeah, yeah. Like I said, we're a global company with a bunch of offices. So I'm sure that there's other teams all around the world using Elasticsearch. I don't know how many, but I could get a number. Wouldn't that be fun? Maybe I'll try to get that number, and then we'll do like a Twitter giveaway at the end or something, or like a guessing game. Yeah, yeah. Sound good? Okay, cool. Well, have fun tonight. I'll be sitting in the back and doing that research. That's good.
All right. Thanks, Jared. Oops. Okay, Kevin, you want to come up and say a few words? Kevin Williams, CTO at Sports 195.
I'm feeling this read. I just got instructions, so it's good. Yeah, I just wanted to, before Karen speaks about how we're using Elasticsearch at Sport 195, just wanted to give you some context about what Sport 195 is. So really what we are is a global network for sports. We have 3 pillars, not in the same context, but it's funny we use the term pillars as well. The one first is core is really athlete. So what the network supports really all sports, all levels, all countries. So we're global, international. But at the athlete level is, as an athlete, you can create a profile, track your, everything you're doing in your life as an athlete. At the fan level, you can really follow anything you want through any sport, any country, any level, whether it's a school, a league, a high school. But it really gives you the ability to follow the sports, and you receive news, videos, images, pretty much anything of interest in that area. The third piece really is, as an organization, whether you're a school or a league or a federation or a government, you can really support your entire ecosystem of sports on the platform. So we've been using Elasticsearch for probably, about how long, Karen? Yeah, for about 3 years. But this should be a brief intro for now, but at the end, feel free to ask any questions about what we're doing at Sport 195. But with that, I'll hand over Karen, who is our expert and that's me getting us up and running.
Awesome. Okay, yeah. So Sport 195 is a global social network for sports. I've been with the company about a year now, and I mainly actually work with search, and I guess I am the search lead there. So we're pretty much just going to dive right in. So to speak a little bit about the data we deal with at Sport 195, we sift through about 100 million documents, and what that means is we have information about metadata and profiles of all different sorts of sports entities, whether it's like an athlete, a team, a league. We also ingest a lot of media, largely through RSS scrapers. We have a lot of news articles, images, videos, and then we also have user interactions. So users use the platform kind of like a Facebook for sports. So we have posts and comments and, lots of threads all over the site. So that's kind of what we'll be referencing throughout the talk when we talk about models or documents. And kind of the ingest rate right now is on the order of tens of thousands of new documents a day. Usually this is in the form of manually submitted profiles of new athletes or teams, and like the scrapers I mentioned before. And one of the hard tasks we have to do is match everything incoming every day to millions of different existing sports entities on our site. So does a news article mention a certain athlete in a certain town? Another fun one is is the article mainly talking about a female or a male sports team? That is basically the gist of it. So how exactly do we use Elasticsearch? We actually use it pretty much to render every page you see on the site. We use it really heavily. Maybe we use it in places we shouldn't be using it. So first of all, we just have entity search, which is a problem y'all are probably very familiar with. You have a certain athlete in mind or a certain team in mind, and you want to find them, which is a weirdly hard problem sometimes. I think you guys probably know that too. Filtered views, in this case, I mean, if you want to pull up all the athletes for a team, or maybe even harder, like all the athletes that were active between a certain period for a certain team, or maybe all the teams in a certain geographical region for a league. So, usually it's like one of the good uses of Elasticsearch is reducing a bunch of joins into one query with filters. We also have news streams for users. So users have their own personal walls, and we serve content, usually in the form of posts or media articles based on what they're following and what they're interested in. And text search, which is searching article bodies for relevant pieces of news. And then lastly, we have a tagging engine, which is what sits between our scrapers and ingesting documents into our database. So here we also use search to see if we currently have something in the database that matches to the subject of an article. Okay. More specifically, we use a lot of very common features. So we need aggregations. We have autocomplete for a lot of front-end forms. We use a variety of different function score queries to kind of rank, have default ranks and sorts different. Routing is in parentheses because we are actually currently in the process of coming up with a strategy to partition our data, which is very hard since it's pretty much everything in our universe has a many-to-many mapping with any other model. And we also have time-based indices and aliases to those, which is another common strategy. Probably read about it on the blog. And a little bit about our search stack, which you can already glean from our meetup post. We are a Scala shop, and we also heavily leverage the Play JSON and web services libraries for the search library specifically. And most of this stuff wraps the Elasticsearch Java API. And we do not use Elasticsearch as a database of record. Right now, everything is stored in MySQL as a sort of backup for reindex. Okay. So we're gonna just continue and dive right into what our Scala library looks like. The motivations for kind of things we considered and built around from the very beginning were pretty practical, I'd say. So we wanted to figure out how to have an easy text DSL for the front end to use, specifically in the form of being able to do, for example, construct any sort of filter you want through URL parameters. We, of course, in Scala care a lot about type safety, which, as you know, Elasticsearch is schemaless. So we want to be able to write and read from the actual class itself. And then we weren't really interested in writing a pure Scala low-level implementation. Really wanted a library that will abstract away most of the setup it takes to get, a table of models into indexed into Elasticsearch and out. So we want to figure out a way to plug and code that with minimal boilerplate. And also, over the course of developing this, we've built in a lot of functionality to aid us in stepwise upgrades, which was really important for the 1.0 upgrade. Okay. Any questions before I start in the code portion? Cool. So, I don't know how many of you are familiar with Elasticsearch or functional programming, but gist of it is that we've mapped the major read and write operations in Elasticsearch to type classes. So these are pretty familiar. And all of these type classes require that you implement a search model mixin. So I will go into more detail about this over the next couple slides. And I'm sorry, I couldn't get the syntax highlighter to work for Scala, so you're just gonna have to parse that out yourselves. Okay, so at the core of everything in our library is just a simple search model, which kind of stores all the shared attributes you would need over all the type classes for reading and writing to Elasticsearch. So this is, everything from here on is kind of a boiled down bare bones view of something you would need to get search up and running. And so in this case, We require that you supply an index name and a type so we know where to put and read your document from. And then we need a client, and then aliases, mappings, and settings are these optional things you can layer on. You also see in this trait that we require your search model be typed to a certain model class. And this is really important later on for type safety. And you'll see it in the next 2 slides. Here is an example. So let's say from here on that we're trying to index athletes and search on athletes. So we have a pretty minimal athlete class, and the way we would actually implement a search model for this would be to type search model to athlete. Oh, I forgot to change a line, but we declare the index name and the type up front in the model, and we supply a client and a way of extracting a string ID from any individual instance of that model that's passed in. So up here on line 5, that is the play.json library at work. So the play.json library gives you the ability to serialize and deserialize JSON from strong types, all under the hood if you choose to use just the built-in macros. You can override this if you need to do anything special, but for the most part, we are going to assume that you have case classes with native types and that you can do something like this. And we will come back to using that in a bit. Okay. We also have an index type class, which is responsible for index creation and handling the logic behind single or bulk indexing operations, which isn't really displayed here for the purposes of clarity. We have, again, an index trait that's required to be typed to a model, and it is also self-typed to a search model. So that means everything you saw in the model slide here, the index name, the index type, the client, it's all accessible from the index trait. The index trait requires that it knows how to serialize JSON from the model to a, the rights requires that you know how to serialize a model to JSON, which is line 8. And then just also on a bare bones level, we require that you know how to build a JSON string from your model, and that has a default implementation of just using the library. And here is kind of what an index call kind of looks like using the Java API. So the idea is that by leveraging the JSON library, there's very few lines of code. You don't have to actually write out all those field serializations yourself. And get is pretty simple. This is just to demonstrate what it looks like to have to read something type safely as well. Same concept with the depending on, the self-typing of the search model. Instead, this time we require you have the ability to read from JSON, and then I just implemented a pretty much what a get by ID would look like. And the cool thing is that you don't get back JSON or a string, you actually get back an option of the an instance of the model you're looking for. Once again, really little code, hopefully. Okay. So what does this actually all look like in practice? This is literally kind of what our code looks like when we spin up a new model to be able to index and get from it. So once again, we have the case class. We've implemented a couple lines of the required fields of the model. And then down here, we mix in our indexing and get functionality. And finally, we can just call the functions that were implemented in those type classes as such. Okay. So next thing would be to talk a bit about search. We have a lot of different functionality baked into our search trait, but it's a little too much for our presentation. So I'm just going with some of the basic things you need and an example of how you would swap out different queries. So once again, you need a search model. Most of these values just indicate that you have a bunch of defaults. Usually when you search, you can hopefully safely assume that most people, when they're searching on athletes, actually want to look in the index in which it was indexed in, as well as the type. You have some defaults for pagination always that you can override. And lastly, the two that we will come back to are using different query builders and using the fields value right here to limit what you actually send back in the query. And internally, we have our own search response wrapper that's actually also strongly typed to the model. So this is a very pared down view. We're just returning a list of the score and the actual document for each of our responses. In reality, it actually pretty much takes the entire structure that you would see doing an HTTP call and maps it with all the underscore fields preserved and with the sources as the actual model instances. Okay. And this is just talking about the fact that the search trait internally also supports these following different types of builders. So if we put it all together now, this is a search object that has the ability to index, get, and search. And if you already have your case class up for a model, this is really just about how much code it takes to get all of the functionality in one object. I didn't put delete on here, but delete is pretty boring. Delete is just another type class we have. Are there any questions so far? Okay. Just going to talk a little bit about more sophisticated things to do beyond just the boring default match all query and no filter searches. So a common problem is autocomplete. Most people use autocomplete. And what we wanted to do was to abstract away the process of having to, duplicate fields you index with different analyzers and then also calling those fields something else and then knowing to search on them. So that's all very cumbersome. So if we revisit our search model, in our library, we actually have another field where you can just list a sequence of strings and to tell the indexer as well as the searcher what is an autocomplete field. And that defaults to an empty thing, so you don't actually have to use it. I removed a lot of the grody collection mapping stuff, but the gist of it is that in our indexer, we actually first serialize our model to a traversable JSON object. And then we build the autocomplete JSON we want to inject into the final document that we send to Elasticsearch by going through those fields that we declared in the search model, and we duplicate the index to a same name field with a suffix. It's a lot of words. I'll show you what this actually looks like in JSON. And so that logic is all built in. You don't have to build it yourself when you spin up a new model. You just have to tell your search model what you want as your fields. Okay, so this is what this would all look like if you wanted autocomplete. So we want to autocomplete the name field. We have another query object called the autocomplete query, which is really just a underneath the hood does a multi-match. And when you index now, the indexer picks up the fact that you have autocomplete fields, and we use an underscore AC as a suffix on all autocomplete fields. So you have that duplicately indexed, and then underneath here, if you use the autocomplete search object that mixes in, a different, that overrides the default query builder with the autocomplete one, it'll know to check the underscore AC fields, and you can search as you would. Okay. So that's the end of the autocomplete example. Another common simple thing is a field restricted search. So, oftentimes you don't want all the fields back in your search, you just want a subset of them, and to reduce network load. And so in this case, let's say we're just, we have a list of athlete names in an autocomplete dropdown. That's all we want. So we would actually first declare that minimal view inside its own class, and we model it that way. So in this case, we just care about the ID and the name. And without having to change any of the code we had previously, we just declare a new search object with the same model because it's looking in the same indexes. And we can just type the get and the search, the read operations to the ref. And the reason why this works is because with the play JSON library, if you have a superset of the fields you want to read in, it'll be fine. It'll just ignore all the other fields. So you can usually create views like this. This is also an example here of just allowing an object to only have read operations. So it's sometimes a nice way to, gate operations. Be like, well, athlete search can index, but obviously, if you have a view search, you can't write to the index. And the last common example we'll go over is polymorphic search. So in the Sports 195 data model, we have a lot of inheritance and subtypes. A couple examples are if you have a lot of different types of geographies. Some of them could be countries, some of them could be cities. They'll all share a core set of fields such as latitude and longitude, but maybe they'll have some different attributes. So we're gonna go over a kind of simple example, redefining our athlete model as a trait with 3 main fields that they all need to have. And we have 2 new models, pro and amateur, that extend from athlete. And pro people have managers and amateur people have friends. Okay, so what would this actually look like? We can actually define an athlete model that's still abstract. So instead, though, we have managed to bound the type of it a little bit more by saying that anything that actually implements or grounds athlete model has to be a subtype of athlete in order to use this index that it's declaring. And up front, we can go ahead and tell you, we know which index it's going to be in, and we know how to get the ID from anything that's an athlete. And then we can extend the specific models, pro and amateur, from the athlete model by typing it and then supplying a index type. I've left out all the implicit reads and writes, but you can actually just put those in with the same lines of code that we saw earlier. And lastly, here are 3 different search views. You can search across all athletes, but you can't index to them because you don't actually know the specific type. But you can index and search and probably get and delete on all with the pro and the amateur search objects. There's some other ways to attack this. So the polymorphism with the subtypes. So in this case, athlete is the intersection of the fields between pro and amateur. We also have cases in our code base where we do the union instead, and then we leave all the fields that aren't in the intersection to be options. It just depends on what we actually want to do with that index level search. That's all I really had time to talk about today. There's a lot of other things we do with this library. We support overrides, so really popular queries. We cheat and we look up what we actually want to return in the search. We also do, as I mentioned earlier, aliases for time windows of news items and media items. And in different cases, even though you're searching on the same data set, you want the actual like sorting behavior, default sorting behavior to be different. So a good example is in our sign-up wizard. If you're looking for a sport you already have in mind, you do want some popularity boost, but maybe you want to know where the user is as well, versus just a search across our entire database for text. We also have a pipeline that can shuttle down geobounds from the controller level down to every single search that's executed, depending on where you are. And we have default aggregations that return. And the last thing, which I kind of wish I could talk about more, is how we handle our stepwise upgrades. And we do so with a mixture of using like the HTTP and the transport client. So we use the Java transport client, but we've actually written a parallel library that just uses the Play Web Services library to send over and read back type safe, index and get and everything responses. We're still building on that though. And that is the first thing here. We're building out our HTTP client, which we would like to start depending less on the Java API, but the main onus there is kind of with a type-safe language, like modeling every sort of response and possible nests with case classes. We're working on getting multi-get and search in place. And with all these different type classes that are strongly typed, we can start baking in templates. And we are also expanding the filter DSL, which I did not get to talk about. That's a specific library we have for parsing flat strings into like infinitely nestable filters from the URL parameters. And that's it. Anyone questions?
You mentioned that you guys are using MySQL
Yeah.
as the
Database of record, yeah.
right. Do you guys have any plans to use Elasticsearch as the primary data source?
So he asked if we have any plans to use Elasticsearch as our primary data store. The answer is not as the primary one, but we actually do want to completely duplicate everything we have in MySQL into the indices, because right now, in certain cases, we have to actually grab the IDs and make another trip to the database to render full views. One of the reasons why we never did that was in older versions of Elasticsearch. Back when we were on like 19, obviously we lost data sometimes, and we were kind of waiting for this 1.0 release, and then gonna wait a couple more, and then make the switch or start indexing fully in it. Yeah. Okay, cool. Thank you very much, guys.
Thanks, Karen.